All right, so we nearly finished 6.2 last time. We had taken a look at a couple of different ways of adding and subtracting with mixed numbers. One option was to keep them as mixed numbers. That might have been a new option for some of you. I know for me, that's one that I wasn't taught when I was in elementary school. And then there's another one, which is improper fractions. And that one's the one I had been taught before. Both of them have benefits and both of them have sort of negatives about them. And so when you come to problems on your own to do, you can choose which way you would like to solve them. So I have one more thing I'd like to talk about in this section before we conclude. And that idea, well, if I can get there, oh my goodness, is about convenient fractions. So convenient fractions are fractions that are roughly equal to what we're given, but they're easier to work with. These kinds of fractions on here would be considered convenient fractions. 1/2, 1/3, 1/4, 1/5, 2/3, 3/4, 1, and there's of course others. But fractions that are easier to work with than say 24 out of 50. Right? That's not super easy to work with, but 25 out of 50, which is a half, that's easy to work with. Okay? So convenient fractions are simply fractions that are close to what we have, but easier to compute with. So they do estimate things. They're not finding exact values. We're using them for estimation purposes only. So we're going to take a look at a couple of examples. The question says to find an estimate to the following fractions, and then to decide if your estimate is high or low. So we just need to figure out a number that's close to the ones that we have that would be easier to work with. And the reality is that when Hannah and when Brooke find them, they may not be finding and give me the exact same answer, and they could both still be right, okay, because of the way that they estimate. So if you were looking at A, 12 over 78, what might be easier to work with than 12 on top and 78 on bottom?
15 over 80.
Okay, so you might choose to do 15 over 80. I think there's an easier choice, perhaps. I would have chosen 10 over 80 because it reduces quicker. So I would choose 1/8 here. If you choose, I have an error in my notes. If you choose 15 over 80, that's fine. You're just going to be reducing a little bit longer. So if I reduce this by value of 5, right there, both divisible by 5, I would get 3 over what? 13? Is that right? That's not right. 14? 16? What am I supposed to do? I'm supposed to be doing 80 divided by 5. What's 80 divided by 5? 16. The last one I got was right. So 3 over 16, that's still not super friendly. I mean, it's better than 12 over 78. But this is probably a cleaner number to work with than the first one. But do you see how it works? We're just trying to round, basically, either up or down, the numbers, so that they're convenient to work with. Now, if I go with the 1 over 8, let's just use that one so that we can talk about this. The question becomes, is this estimate high or is it low? In other words, is the 1/8 smaller or bigger than 12 over 78? Does anybody know? You think it's smaller? The 12 over 78? Which one's smaller, do you think? Who said smaller? I don't even know. Summer, are you talking to me? Sorry, I'm trying to, as soon as I look for somebody's mouth moving, you guys have stopped talking, so I can't figure out. Summer, you think which one's larger or smaller?
I think 1/8 is smaller.
You think 1/8 is smaller. Okay, so one of the things to try and figure out is what happened to the numbers on top and on bottom. And sometimes when we manipulate them, it's hard to tell. This one's actually pretty nice. Let's just look at the denominator first. If I had left my numerator the same and I only changed the denominator, what happens when I take 78 and I make the denominator 80? It makes it bigger. If the denominator is bigger, what happens to the fraction? It gets smaller, right? So the denominator gets bigger, the fraction gets smaller. And very nicely, the numerator has the same thing happen because the numerator is bigger and it becomes smaller. The fraction also becomes smaller. So the top and the bottom both changing the way they did made the fraction smaller. So this is a smaller number, right? Which means that this is a low estimate. It means it's actually less than what that value would have been. I don't think that there's any questions that ever ask you to justify like we just did out loud. So while I'm not advocating switching them into decimals, if you would like to do it from that approach, that's okay. We haven't gotten to talk about decimals yet, but that's another way to think about them. All right, 2 over 1001.
500,000.
You could do 5 over 1,000. I think you probably even could just do 2 over 1,000. It would be okay. I don't know that we necessarily have to change that, because if we changed it, sorry, that should say approximately. 2 over 1,000 is approximately what? 1 over 500, which that's a really close estimate, agreed? Really, really close. And it's convenient in the sense that I've got 1 over a number. So this is pretty good. If you did 5 over 1,000, Beth Ann, that's fine. It's not going to hurt anything. You know, we're not going to split hairs here. But question then, is this estimate a high estimate or a low estimate? It's a high estimate. So why is this one a high estimate? Yeah, if the denominator got smaller, then the fraction itself got bigger. That's exactly what happened. Any questions on those two? All right, so here in a second, we're going to do group work after we've looked a little bit more in 6.3, and then this set of problems, your homework and group work, will be due next class period. Everybody good? Awesome.